Hello, my little mathematicians. This is Mrs. Brown, and today we're going to go over solving linear systems by substitution. We've already gone over how to solve linear systems through graphing, so I'll expect you to know what a linear system is. And just as a reminder, the solution of linear systems is the point where both lines intersect. So today we're going to see how to solve it algebraically through substitution. Now we have these two equations, y equals 3x plus 2 and x plus 2y equals 11. So the first step is we have to make sure that one of the equations are solved for one of the variables, or in other words, one of the equations are set equal to one of the variables. If we look at our equations, we see that y equals 3x plus 2 is one of our equations that has already been set to equal to y, or it has been solved for the variable y. So now that we already have one of the equations set to equal a variable, we can continue on to step 2, where we take 3x plus 2, which is what y equals, in the first equation, and we substitute it into equation 2 for y. So we input 3x plus 2 for y, and we solve for x. By substituting it in, we get x plus 2 times 3x plus 2 equals 11. We then simplify it by distributing the 2 into the parentheses, and we get x plus 6x plus 4 equals 11. When we add like terms, we eventually get 7x equals 7. Thus, we divide both sides by 7 and we find that x equals 1. Now that we have our x, we can then take 1 and substitute it into our first equation to solve for y. So when we take 1 and we input it for x, we get y equals 3 times 1 plus 2. When we simplify it, we get y equals 3 plus 2, which further simplifies to y equals 5. Now we have 2 points, 1 and 5, that are a possible solution for linear systems. Now, as we love in algebra, we're going to check our solution. So we're going to take our x-coordinate of 1 and our y-coordinate of 5, and we're going to plug it into our first equation. So we're going to take 1 and we're going to put it in for where we have x. We're going to take 5 and we're going to put it in for y. So we get 5 equals 3 times 1 plus 2, which simplifies down to 5 equals 3 plus 2, which fully simplifies to 5 equals 2. So it is a true solution for that equation. We're going to do the same thing with the second equation. We're going to input 1 for x and input 5 for y. So we get 1 plus 2 times 5 equals 11, which simplifies to 1 plus 10 equals 11, which equals 11 equals 11, which is true. So we have proven and checked that 1 and 5 is a true solution for that equation. Now we got lucky with those two equations, because y already was set up to equal the rest of the equation. Now what do we do if we have two equations and none of them are set up to equal a variable? So we choose one of the equations that we think would simply be very easy to change to equal either x or y. So looking at our two new equations, we have x minus 2y equals negative 6, and 4x plus 6y equals 4. Looking at them, I see that x minus 2y equals negative 6 would be very easy to change and equal to x. So if I add 2y to both sides, I get x equals 2y minus 6. And now my equation is already solved for a variable, and I can take that and input it into my second equation. So then I take 2y minus 6 and input it for x in my second equation, and I solve for y. Inputting my 2y minus 6, I get 4 times 2y minus 6 in the parentheses plus 6y equals 4. If I distribute my 4 into my parentheses, I get 8y minus 24 plus 6y equals 4. And when I simplify and add like terms, I then get 14y equals 28. Now I can solve for my y and I get the number 2. Now that I have 2 for my y, I can take that and input it into either one of my equations. For simplicity's sake, I'm going to take equation 1, which I had solved for x. So I'm going to take 2, I'm going to put it in for y, and I get x equals 2 times 2 minus 6, which simplifies down to x equals 4 minus 6, which then equals x equals negative 2. Now that I have my 2 coordinates, I will check my solution by putting negative 2 in for my x and 2 for my y. So taking my first equation, I put negative 2 in for x, 2 for y, and I get negative 2 minus 2 times 2 equals 4, which simplifies to negative 2 minus 4 equals negative 6, which is true. I then take those points and I input it into my second equation, and I get 4 times negative 2 plus 6 times 2 equals 8. It simplifies to negative 8 plus 12 equals 4, which simplified comes out to be 4 equals 4, which is true. So negative 2 and 2 is a true solution. In conclusion, we've seen that using the substitution method, we first have to solve one of the equations for one of its variables, or set it equal to either y or x. Then we have to substitute the expression from step 1 into the other equation and solve for the other variable. Once we have solved for the variable, we then substitute that value into the revised equation from step 1, or you could technically put it into the other equation. But then you would solve for the other variable.